Okay, today we're doing a little bit of review and then doing some evaluating of logarithms by changing the base. All right, just as a little warm-up, let's review writing the inverse of the following. We have y equals log base 2 of x. Remember to write that as an exponent. It's 2 to the y power is equal to x. And in order to take the inverse, remember we exchange x for y. So that would be 2 to the x power is equal to y. And we'll indicate that it's an inverse with a -1. Right, number 3, sorry there's a mistake in numbering here. On number 3 we have x cubed is equal to y. So remember we're going to exchange y for x. Here we need to solve for y, so we're going to take the cube root of each side. So that's the cube root of x. And remember to indicate that it is the inverse. Okay, and number 4. We're first going to write it as an exponent, so it's 5 to the y power is equal to x. Remember to exchange x for y and to indicate that it's the inverse. Okay, part of the reason we did that review is to help us when we're graphing logarithmic functions. And here we have a logarithmic function, y equals log base 3 of x plus 1 plus 2. And first thing we want to do is find the parent function. That's the function without any transformations. And that would give us y equals log base 3 of x. These transformations, remember that's h and k, so the h would be -1. That means our graph is going to be shifted left 1. And this is k, that means our graph is going to be shifted up 2. All right, now we rewrite the function as a logarithmic function, so it's 3 to the y power is equal to x, and then exchange x for y to find the inverse. And that's the function we're going to use in order to graph it. We're going to create a table, and I like to use -2, -1, 0, and 1, 2 for my x values, and then plug them into the inverse function. That's 1/9. 1/3, 1, 3, and 9. I'm going to graph the points, but I don't want to graph this because remember this is the inverse. So I'm going to exchange my x's for my y's and graph those points. So I will graph 1/9, -2, do 1/3, -1, I'll do 1, 0, 3, 1, and 9, 2. Now remember, this is my graph without the transformations, so now I'm going to take those points and I'll do the transformations. That's to the left 1 and up 2. So left 1, up 2, left 1, up 2, this point to the left 1, up 2, left 1, up 2, and left 1, up 2. And there is the smooth curve for my logarithmic function. Remember that we have an asymptote here. The asymptote is the point where the line, is where x is equal to h. Here h is -1, so I should indicate my vertical asymptote here. All right, and that is our warm-up for today to get us started. Okay, now we're going to be evaluating logarithms. And remember when we did this, we had a procedure we used. The first thing is, if we wanted to solve x equals log base 3 of 81, our first step was to convert the logarithmic function to an exponential function. Then we found a common base, set the exponents equal to each other, and solved. Well, what if we have a problem like this where we have x equals log base 5 of 3? To rewrite that as an exponential function, it's 5 to the x power is equal to 3. Now we have a little problem here because we cannot set our bases equal to each other at any point. So in this case, since we don't have a common base, we're going to actually use our tool, which is our calculator.